Whether it's sitting by the hot fireplace in the summertime or at a concert, everybody loves the guitar.
The history of the guitar can be tracked up to 4,000 years ago. Ancestors of the modern guitar can be tracked to Central Asia or India. It has a mention in records maintained by the Vikings.
It is often claimed that the guitar is a development of the ancient Greek instrument, the guitar.
The earliest ancestors of the guitar are known to archaeologists as the bullharps and the tamburs. The oldest guitar known to man is a 3,500-year-old Egyptian guitar that belonged to famous singer Harmos. This guitar was also buried with her tambur. Archaeologists have found many relics in the ruins of ancient Persian and Mesopotamian cultures. Many of these instruments have made it into modern time with almost unchanged form. As you can see in this, a guitar makes its sound as a result of vibrating strings, which are tuned to certain notes. It uses frets to limit the vibration of the string, inevitably changing the length. In all kinds of guitars, the sound originates from when the player plucks each string. Since the strings can only displace a little bit, the sound is not very great. So then, what's the point of playing a guitar if you can't even hear it?
Well, we use the law of resonance to help us amplify the sound.
An acoustic guitar is composed of a headstock, a neck, a body, a sound hole, and a bridge.
There are three components in producing sound in a guitar: the strings, the body, and the air inside. So what happens is when you pluck a string, that string sends a vibration to the bridge, which sends a vibration to all the air inside of the guitar. When that happens, the sound is resonated inside the guitar and comes out the sound hole amplified. Since the body of the guitar is hollow, it allows sound waves to travel throughout the entire inside of the guitar. The air inside of the cavity resonates with the motion of the string. To demonstrate how this cavity amplifies the sound of the string, I will conduct an experiment where I will place a paper in between the string and the cavity hole to block off any additional noises coming from inside the cavity. Listen closely as the piece of paper is removed. This right here, the surface is called the soundboard. This is called the sound cavity. So what happens when you pluck a string is the sound or the vibration is carried throughout the entire string. This vibration carries on to the bridge, which is attached to the strings. This bridge then vibrates the soundboard. Clearly, the area of the soundboard is much, much greater than the area of this single string. Therefore, this entire board vibrates, displacing much more air than just this little string, therefore creating a much louder sound. As the soundboard vibrates, sound is produced from both the front end and the back end of the guitar.
In addition to the resonance from the sound hole, the soundboard amplifies the sound even more. There are four major factors that determine the pitch of the sound that's resulting from the string. The first factor is the length. The length can be determined by pressing down on the string at different places on the fretboard, as you can hear from here. Those are two completely separate noises because the length of the string was altered. The second factor is tension. The tension can be determined by moving any of these knobs. For example, the higher the tension, the higher the pitch of the sound. The diameter that can affect the pitch. This is also known as the thickness of the string. As you can see, this string is thicker than this string. The thicker the string, the lower the frequency because it is harder to disturb the string. The fourth factor that affects the pitch of the sound is the density. The density of the string is determined by the material the string is made of. Every material has its own density. The higher the density, the slower the vibration of the string, and it is harder to move the string. Therefore, the lower the pitch, and vice versa. An acoustic guitar has soft plucking noises that sound blended. The sound is amplified by the sound resonating in the sound hole and is amplified by the sound board.
The acoustic guitar is mainly used for softer music, such as country and classical. An acoustic guitar's strings can either be made from nylon or steel. The electric guitar strings are only made from steel. This causes the guitar to have a much sharper noise. Electric guitars are mainly used for rock music. This is due to their ability to alter the sound with the use of distortion knobs or pedals. Since an electric guitar does not have a resonant hole, it depends on an electric amplifier to amplify its sound so it can be heard much louder. Listen closely. The electric guitar could produce a much larger variety of noises compared to the acoustic guitar, which can't be altered by the use of electricity. However, on the other hand, the bass guitar only has 4 strings instead of 6 like the electric guitar and the acoustic guitar. This allows the player to only produce E, A, D, or G notes. The bass guitar cannot be heard unless it is hooked up to an amplifier. Since it only has 4 strings, this means the bass guitar has a much smaller range. So what we've learned is the guitar is a very old instrument that dates back into ancient Greece and Egypt. The guitar mainly relies on the player plucking one of the strings, which then sends the vibrations to the bridge, then sends it to the body, and then finally into the air inside of the guitar, which then it comes out of this hole. The guitar mainly relies on resonance to amplify its sound. Finally, the 4 factors that affect the pitch of the sound coming from a guitar are density, length, diameter, and finally, tension.